Before I jump into the talk, I just wanted to give a very, very quick idea, considering that the topic of tonight is mostly giving presentations or presenting in front of people, things like that. I gave my first talk probably about a year and a bit ago, and of all of the things that I could possibly have done to either better my career or to expose myself to more interesting parts of the community or more interesting parts of the language, speaking is probably the best thing that I've done to improve that. I can't recommend enough taking the chance to get up and speak to the people in the community, to get used to delivering your ideas, to get used to speaking either off the top of your head or with something prepared. Everything that you can do to kind of take that chance immediately feeds back positively for you. So yeah, I highly, highly recommend it. The talk that I'm going to give now is a little bit of a reprise of the talk that I gave at JSConf a couple of weeks ago. For anyone who was at JSConf or for anyone who watched it live streamed, I apologize. I hope actually no one, was anyone here at JSConf? A couple of people. Anyone has already seen or heard of this talk? More or less the same people. I apologize to those people. Basically what the talk is on is mostly on code structure, but the majority of what it's really on is on communication. And the concept of the talk is that we as developers have the ability to make decisions that are either going to be better or worse for our time as a developer in the project that we're on. So we have the ability at the beginning of a project or at any point through the project to make a decision and say that this is how I'm going to do the task that I'm doing. For people who are just coming into programming or just starting, you have a responsibility but also a privilege to be able to do the work the way that you think it should be done. And this is really very powerful. It's a kind of work that you get to do every day where you get to make decisions about how you get to do something. So that's really the takeaway from this talk. I guess cover very quickly who I am. Anyone who doesn't know me, I'm Jacob. I work at a company called ThinkMill. I hate the phrase full stack developer, but I guess kind of applies. Mostly JavaScript, mostly Backend, mostly Node.js, with a lot of interest in doing things better or improving processes and improving standards. For the last couple of weeks, everyone in my office has heard me sound like this person. Continuously, whenever a problem comes up, I have a refrain, which is that we should change it to a monorepository. We should build a monorepo over and over and over again. And this is basically what I'm going to cover off in the talk today, is the concept that there is a folder structure and a repository structure and a directory structure that will help you make better decisions about your code. The underlying principle of the talk is that good architecture costs less than bad architecture. And what I mean by that is, when you're rushed to get something out, you're not going to make good decisions. When you're in a hurry to implement something or to ship something or to deliver something, you're going to deliver it as quickly as you can, but you're going to either make decisions where you kind of cut off features or you don't deliver something as properly as you could, or you're going to miss tests or you're going to miss a client requirement, and you'll have to come back later and fix it up. And if you're working for a company that delivers as an agency, your client probably isn't going to pay you to come back and fix things the way that you should have done them. If you're working for a product company, your company is going to pay you to fix the mistakes that you made or to pay you to rebuild the features that you should have built initially. But you're going to be spending someone's capital in doing that. If you can see the right way to do it up front and you can deliver that up front, in the long run, this will net you an easier experience as a developer, but it will also net your company a more positive return on their investment. So here we have an example of bad architecture, poorly thought out architecture. And very easily we can look at this and see, if I had been looking at that initially, I would have known exactly what went wrong there. But everyone's written code that looks like that. Everyone's written code with a function that says, I will not return 1, that returns 1. Everyone's written code that has a comment above it saying, come back and fix this later, and then not fixed it later. Everyone's code bases are full of to-dos and fix-me's. This is an example of a to-do and a fix-me. So I'm going to talk a little bit about the laws of communication. The almost too quoted display on the slide is by a person called Conway. And it's structured as Conway's law. And essentially what it means is that the way that you communicate to your peers and the way that your company communicates with you will be informative on the way that you build software, on the way that you design solutions. So what you can take from that is your day-to-day communication will inform the way that you write software. What I want to take away from that in this talk is that the way that you write software can also inform the way that you communicate. And that's what really the meaning of this, this phrasing is that you have the ability as a software developer, as a software engineer, to influence the way that your company communicates by enforcing certain standards and patterns in the code that you write. And we'll cover off one of those possible standards today. So with that in mind, thinking about communication patterns, think about what your organization looks like. You might be just coming into software having never used it before. You might be someone who's been working in the industry for 10 years, but you should have a fairly clear idea of what your day-to-day communication looks like. So we'll start with the idea of a monolith. And a lot of companies are monolithic. A lot of companies start with one person at the top dictating terms and people kind of operating on them as they go. We have very, very strong standards. We have very easy to understand communication patterns. And we have very, very tightly bound understandings of what the company's goals are. And this will tend to produce software that is very, very tightly bound, very tightly coupled, where every piece of the company is very, very much involved in the software of other pieces of the company. So an example of that is a project that I was working on a couple of weeks ago, which is a small to medium-sized node application. It has 416 distinct JavaScript files, and in that has 27,000 lines of code. This is one application where all of the communication about this application came in through one team, and therefore all of the code was in one team. All of the code was in one repository. All of the different requirements and features were all in one place. We have what is called a monopurpose structure, and a monopurpose structure is a collection of many modules, many repositories. And the idea there is that when you have one thing that does one thing well, you isolate it into its own repository, into its own structure, and then you share it. And Node is really good at this, or JavaScript in general is really good at this. You have a lot of modules now, thanks to NPM and thanks to the Node modules structure, where tiny little bits of code are isolated and architected in such a way that they can be shared between as many applications as you want. This tends to reflect well on teams that are distributed throughout a company. So if you find yourself in a company structure where you're working on your own thing inside your company's larger goal, and you have a lot of these teams individually, it's easier for you to ship changes in your own part of the world and then kind of constrain to some well-held API between all of the different parts of the company than it is for you to kind of run everything all together but be able to talk between all the different teams at the same time. And so an example of this is the Keystone repository. Or the Keystone project, rather. The Keystone project has a number of different repositories that are all individual repositories that all run by themselves, that are all shipped and deployed by themselves, and they manage to talk to each other, but they're all run by different people, by different teams. Finally, we have a monorepository. And for the people who've seen the talk already, they know exactly what this is, but the idea here is that there is something that you can do that gets you the best of both worlds. That you get some way of having isolated concerns and some way of getting individual deploy candidates, but you also get some way of sharing code in between systems without coupling things too tightly. So let's have a look and see how they perform and why we might be interested in comparing a monolithic repository, a many-purpose or a monopurpose repository, and a mono-repository. So we'll look at the first test, deploying a release. So this is a test where we're looking at inside a monolithic repository, we have a single deploy candidate. We have one piece of code inside a monolith that we're going to send somewhere. In a monopurpose repository, we have a number of different repositories that all map to a number of different deploy candidates. So we're going to send a number of things into a number of places. And in a mono repository, we have a number of different deploy candidates that are inside one repository. So we have one place where the code lives, but we send it to many places. And so for a monolith, we have a single deploy command because we have one repository. So we send something to one place very comfortably. When we have a monopurpose repository structure, we end up using bash to iterate a number of folders, to run the same command in a number of folders and deploy things to NPM. Possibly then we have an NPM webhook set up to listen for any events that are happening on NPM and deploy servers based on release candidates. It can be very complex very quickly. And this is a side effect of the fact that having a lot of different places where you have to commit code can make having standards across all of those different places that you commit code a little bit more difficult. Finally, for a mono repository, we have a single command again. And the reason for that is that even though we have a number of different deploy candidates inside the mono repository, they're all inside the same code structure, they're all inside the same hierarchy, which means that even though they go to different places and they run in different ways, it's very straightforward to write something that executes each of those commands in one command for you. Now, what we want to minimize in general is the number of actions we have to take to get to a goal. That's a lot of the goal of programming, is minimizing the complexity between a requirement and a goal. And so what we end up with here is as many actions as you need, but you write them and test them thoroughly in one place and then execute them. So this is the advantage of a mono repository. So we're going to look at sharing common functionality between projects. So again, we have a monolithic structure where we have all of our code in one project, which by definition means we can't share code from the monolith because all of our code is in the monolith. If you have a company that has one product or one feature, this is probably okay because all of your code is going into this one place anyway. As soon as you have a company that might have multiple features or multiple products, it becomes more difficult to share code in between them. And as soon as you start extracting code out of a monolith to share it in between different monolithic structures, you now have a monopurpose structure. So you're already moving towards something that makes it easier for you to share code. If we look at a monopurpose structure, it's very easy to break out individual pieces of code and share them in between different parts of your application. This way you can easily identify the smallest possible feature that has its own interface and its own reason or responsibility to exist, break it out into an NPM module, and share it. Finally, if we look at a monopurpose repository, a monopurpose structure, we have the same ease if we look at a monorepository, it has the same ease as a monopurpose structure of sharing code in between multiple projects, but what we end up with is a very, very easy common structure between all the different projects. The big advantage of using a mono repository in this circumstance is that you can actually test all of the interfaces against all of the other required places where the module is required inside your project, in such a way that you can see any change that you make might be breaking or might not be according to the tests of all of the things that might depend on it. So the last thing that we're going to look at is to make atomic changes. So an atomic change is the concept that if you do one thing, all of the changes that happen as a result of that are able to be done in one operation or rolled back in one operation. And what we want to be able to do is, in our system, we don't want to have to make a change, go validate, did the change work, go somewhere else, make a change, validate, did the change work, go somewhere else, make a change, did the change work. This gets exhausting, and it turns what should be a simple deploy process from one command and one check to deploy the server, go check the server, go to the server's dependencies, deploy the server's dependencies, check the server's dependencies, deploy their dependencies, check their dependencies. In a monolith, you don't have a shared system, so this point is kind of moot. In fairness, in a monolithic structure, you are deploying one thing. So atomically, you are pulling back one thing. But you don't have any way to see that change happen throughout a web of dependencies. You're constrained into one area of the code base. A monopurpose structure cannot do this. By definition, because each of the pieces have to be deployed independently, their individual deploy processes can be deployed atomically, but the entire system is going to happen as a result of any number of the pieces working or not working. If anyone's had to deploy a release process where something at step 15 broke, and now you don't know what state your system is in, this is a direct result of following a monopurpose structure. You have a lot of different pieces in a lot of different places, and you have to chase them up as you go. Finally, with a monorepository, you have the ability to make the required changes where you need them, commit them, push them, and then in a single command, watch those changes flow out through your entire system. The changes themselves might still happen in independently from each other. But the command that you use to update the system is a single command, and the changes that you put into the system are a single set of changes. And that means that rolling them back from one known good configuration to another known good configuration is much simpler. So with that in mind, we can see that while the monolith performs relatively well at atomic deployment, and the monopurpose performs relatively well at sharing code in between modules, the monopurpose is the only one that really performs well in all of the situations that we might deal with in day-to-day development. So looking at that now, let's touch on an example of what monorepository development might look like. And I'm going to come at this from the very, very beginning of I have no code and I'm starting a new project, and how do I begin? Before I take too deep a step in that, the stuff that I'm going to show, the details or the demonstration that I'm going to show, uses a tool called Lerna. And Lerna is a tool that was born from Babel, the transpiling project. It was a tool that was born from the change from Babel 5 to Babel 6. Initially, Babel was completely monolithic, and the change from Babel 5 to Babel 6 made it much more modular. But there was a tremendous difficulty in making changes to all of the different modules at the same time and deploying them atomically. So the developers of Babel built this tool that allows them to make changes throughout their entire module ecosystem, and that's the tool called Lerna that I'm going to show here. Outside of Lerna, which is a very well-developed tool, there are a number of other alternatives, which is Builder by Formidable Labs, and a pattern. It's not a tool, but it's just generically kind of taking advantage of the way that Node resolves modules, which I think is pronounced Ale, but I don't know. I've only ever read it, I've never heard it. But this basically is a way to take advantage of Node's module resolution algorithm and perform the same kind of monorepository structure tooling checks that you need without having to buy into an external tool. Outside of all of that, there's been talk recently of Yarn integrating Lerna directly into Yarn. So in the next couple of weeks or months, there might be something built into Yarn that allows you to treat every project like it's a monorepository. So given that, you should feel free to run these kind of things yourselves. It probably only takes 100 lines of bash scripts, if anyone is comfortable writing 100 lines of bash scripts. But it's not hard to approach. It's not hard to get started with. And equally, if you start working with Lerna and then decide that you want to eject and go and do something else, it's not difficult to eject from that system. So we'll take a look into the setup. So the initial setup for Lerna is a single command. You run Lerna init. It builds out the entire project structure for you, generates all of the different folders you need and the files that you need to get started. We can see that here, the structure of an initial Lerna repository, an initial Lerna project. This includes 2 folders that I've created with the files in them. This is exactly the same as if you'd run npm initialize and then built out a project from that. I've done that twice inside the packages folder, but used those inside what my larger Lerna repository is. Finally, each of the package JSONs end up with whatever the structure that you need for your package JSON is. In this case, we have a name, a version. It's exactly the same as an ordinary JavaScript module, or as an ordinary Node.js module. What we have after that is a command called bootstrap. And what Lerna does is it will take each of the packages in your packages folder and check what their dependencies are. And if it finds any of the dependencies in your package JSON in any of the folders that you've created in your packages folder, it will symlink those together so that any change that you make during your development shows up in your live projects as you're working on them. So it's a very, very tight development loop where if you make a change to one project as you're working on it, it immediately shows up in the development of your other project. This way you can make interconnected changes throughout a bunch of different systems, commit them together at the same time, deploy them at the same time, and see that their changes work with all of your latest branches. And then at the end of that, you can see here, so the demo header relies on the demo button. And we can see that in the node modules folder for the demo header, we have a symlink from the demo header folder into where the development folder for that package is. So let's look at adding some code. We start with what our standard tool chain probably would be. We throw in a Babel CLI, we grab some presets, but what we should notice here is that we only need to add development dependencies to the very, very top of the tree. Because node modules will resolve from whatever folder it starts looking in as far up the tree as there are folders to traverse up, you can keep all of your dev dependencies that are shared dependencies at the top level of your project, not inside each individual module. Less of an issue now that Yarn install is faster than npm's, but still probably saves you about a gig if you have a large project and a lot of Babel presets. We then have this structure here where we have a node module, where we have our package structure like we had before. We've now added a source folder with an index.js in each of our components. So this is what it looks like, standard React component. We export a default header, and you can see here that we're importing a button from the demo button folder. So what I'll touch on here is inside the packages folder, there's the demo button. The demo button says my main file is this file. We're not importing the demo button during development from like a relative path that we're walking. We're not doing anything in our code that's different from how we would normally develop a component. Lerna takes care of making sure that where we expect the file to be, it is. Then we have a couple of scripts, and this is where I say that you can make this as complex or as simple as you like. These scripts are relatively straightforward if you've been working in this ecosystem for a while. If you're newer to this ecosystem, there are a lot of defaults that you can get out of the box with Lerna, and some fairly good tutorials to guide you on what your desired development workflow might be. But what you will be able to do is, from the root level of your repository, from the root level of your project, build every component in your project, watch them and see that any changes you make to the source code is reflected in the development candidate that you're working on. See how they interact with each other, run them as code that is integrated together, and then eventually test them in integration with each other or deploy them in one step. So I'm all about the developer experience. I really like building things that are nice for developers to use. And this is something that I think is really, really nice from this system, is that instead of having an individual development test bed for every piece of your project individually, you can actually run a single development test bed for all of your packages at the same time. So what we have on the screen here is a single npm watch command being run, and a project called React Storybook that allows you to run all of your components together, essentially inside a Webpack compile process that will give you this nice little harness where you can click through each of the different configurations and see the changes get made live. So that's what's happening on the screen is I'm running npm run watch from the root of the project, and we can see that it starts to pick up changes to the two components. And when I run Storybook, it builds a Storybook and runs it on the port, and then I can open up the file that I want to edit. So here I'm editing the button component, and I have any text as the text in the button, and you can see here it says any text on the button. When I make the change to some text, it hot reloads into some text. This change will be reflected anywhere in the project, which I'll show in a screen. So when we make a change to our core components, when we make a change to anything that is a dependency of something else, the change is reflected live. So here we have the same Storybook running, but instead here I've added styles to the button. And we can see here that the changes to the styles of the button are reflected live, not only in the button, but also in the header component that is just taking advantage of the fact that node modules changes will be picked up by Webpack and picked up by Storybook. So we have a very, very tight development loop and a very good integration of the different developments of components that we might want to use. So I've shown it a little bit on the front end. Is it only for the front end? No, you can use it just as easily with backend components, just as easily with servers, just as easily with any aspect of your development hierarchy. In this case, I've put together a server, an Express server, and the Express server is just there to serve the content that the button and the header have. And it's an ordinary Express server. It has all of the same files that you would normally use to build an Express server, and it listens. But equally, any change inside the component that's inside the Express server will pick up any changes to the button or the header. So here is a file that is sitting inside the server. This file is inside the client folder inside the Express server. And you can see it just imports header from wherever the header is and uses it inside a page component. But any change to the header, when I'm editing the header directly, will show up in the Express server's dependency code as well, which means that the Express server will serve the changed code as I'm working on it. So this is quite powerful if we're building integrations, but we want to be able to see changes in isolation inside the individual packages, and we also want to see changes wherever those packages are used. If we're working in a system that has many different backends that are serving these components, but we're giving the components to multiple different teams or multiple different projects, this is an easy way to see the integration between each of these points. And at the end of it, this is what the system will look like. So we have a header with a button and a page, which is a landing page. And you can see that my CSS and my design skills are not that strong. But what we end up with is the way to compose all of these different pieces together in a declarative way, where the change to any of them will show up inside any of the other components that you're working on at the time. And when you're ready to say, this is now what the state of my system looks like, you commit it like you would commit your code ordinarily, you push it, and all of your changes move as an atomic commit. And so we can see the deployment process, or the publish process, is more or less what you'd be used to by running npm version, npm publish, but it gives you an interactive API. So when you run Lerna publish, it will say, here are all of the different pieces of your system that have changed. What version would you like them to change to when you publish them? And you can choose if it's a patch version or a minor version or a major version. Our host, Atlassian, is working on a semantic release tool for this, or was at some point and might still be, which is an awesome system which I encourage people to look into, which will allow you to automatically, through either commit messages or through markup, allow you to say, when I push this and it goes through CI, automatically publish each of these projects at each of these versions, which means you take out this manual publish step entirely, which is a very powerful tool. So that probably doesn't look very different from how you normally commit code. And it isn't, it shouldn't be. Realistically, everything that you would normally do with a project, you should still be able to do with the code in a monorepository. But the advantage here is that to start to get the benefits that I outlined, you don't actually have to make a massive change. You can make small iterative changes towards this system and still retain all of the comfortable ways that you work now. The idea is that you don't have to buy in one go, and you don't have to sell anyone on having to make this massive change in one go. So everything is good, everyone's sold, we're all gonna start moving to monorepositories? Not quite, and not necessarily. Depending on what the structure of your organization looks like, and depending on what the structure of your code base looks like, this might not be an easy change or an easy system to buy into. So Git checkout slows down majorly. Has anyone accidentally committed a large Java jar file to their JavaScript repository? Has anyone, how long did a Git commit, or a Git checkout go to?
The checkout or commit?
No, the checkout.
The checkout? Oh, yeah. I don't know, like 15 minutes.
So you end up with what should be a 5-second operation become a 15-minute operation. That's purely because the number of things that it has to keep track of and the size of the repository that it has to clone or check out slows down almost in proportion to the size of it. Now, this is fine when you only have one project and one set of files. If you have 100 projects and they're all inside a monorepository and you're trying to check out the entire monorepository, that might be a slow operation. There are ways to get around that, and there are things that you can do to mitigate that, as well as sometimes Git might not be the right tool, and there are other version control systems like Mercurial that perform better at that massive scale. For most people who are working in the systems that we're working in, this probably isn't a scale you hit early on. Similarly, creative tagging. So because you're making a lot of changes to a lot of different systems, at the moment we're probably tagging each release at a release. But when you've got 4 or 5 things being released at different versions, how do you tag them? And this is something that is really up to you and your teams. You might tag a release in multiple ways. You might tag just whatever the most breaking change is. But it does make this a little bit more difficult and something that you do have to deal with. Build tooling is something that you need to develop. So I showed an example of the kind of scripts that you might write otherwise. I really like Bash. I really don't mind working in it. I also like Makefiles, so that might make me the oddity at a JavaScript meetup. But the tooling around monorepositories does mean that you need a way to apply changes to a bunch of different contexts. The tooling around a front-end component and the tooling around a back-end component are going to be different by definition, and you just need some way of telling, is this a front-end component or a back-end component, and how should I run it? So a middle ground, there's one thing that you can do that allows you to keep all of your code separate, but treat it as if it was a monorepository. And that's a tool by Feros called Zelda, where the tagline is, sometimes Link needs a little help from Zelda. And what this tool makes it easy for you to do is to npm link all of your packages together. So you clone all of the things that you want to work on into a single folder, and at the top of that folder you run Zelda, and it will go into each of the packages and say, what are my dependencies, find the dependencies in this folder, link them into me, and then I can start working. So it's very similar to the Lerna bootstrap command, but it allows you to start working on multiple repositories as if they were a single repository. So to recap, Oh, sorry, yeah, to recap, one step too far. These systems allow you to make decisions. I feel they allow you to make better decisions over the lifetime of a project. They'll save you pain, they'll save you time in the long run, and they'll make it easier for you to make good decisions. And that's really what software should be built from, is good decisions. So that's that. Thank you. Do you want to check that that one's enabled?
Enabled. Do we have one question for David before? We do have one question for David.
Hey, you mentioned like using a single Git repository. Have you tried some modules, like sub repos?
Yep.
How does that work?
So, for anyone who's not familiar with sub-modules or sub-repositories, Git, which is a version control system, will allow you to keep track of whatever changes you've made to your code over time. And what that means is that it will compute a unique identifier for whatever your collection of code looks like at the time that you've said, this is a point that I want to remember, or a point that I want to commit. What you can do then is you can tell Git, not only do I want you to keep track of the code that I'm working in here, but somewhere else there's a project that is also a Git project that is also a point in time that I want to keep track to. And I'll bring that into my project, but only at that point in time specifically. So that's called a Git submodule. And what that allows you to do is to be able to run your project and refer to code in another project as if it was inside your project, but not have to keep them together. So that's what a Git submodule is that was referred to. And the question was, with the ability to say, I'm inside a repository and I can reference other repositories, what's the reason for a monorepository? Or what's the difference between a submodule and a monorepository? And the idea is that instead of treating your version control as a concern, where you're trying to say, I want to separate all of my projects and their repositories by the submodule so that they're stored in different places, you are able to keep all of your code and all of your changes in one place. So the downside to the submodule way of working with things, where I've seen it used in the past, is that you still have to go through to each of those repositories and make a change and commit the change and push the change. And similarly, when changes have been made to those repositories, you don't pick them up immediately. You have to go through each of them and sync them or update them or clone them or whatever your process is to build up your submodule tree. So that's really the difference and the change, is that instead of having all of your changes take place in separate places and still be accessible together, what you have is all of your changes take place in one place and be accessible together. That's the distinction.